Okay, so in this video, we're going to talk about our fourth exponent property, which has to do with negative exponents. So let's make sense of this situation. Let's say we have something like a squared divided by a to the fifth power. So we have the same base for both the top and the bottom, and if we're using division, our rule is, okay, we take the top number and subtract the bottom number. So what this is really the same thing as, this should be the exact same thing as a to the 2 minus 5 power. And if we clean that up a little bit, we should get something like a to the negative third power. Okay, that's a perfectly good answer, but one of the rules we're going to have with math is that we don't want to have negative exponents. So write that somewhere. Negative exponents equal not finished. We have to get rid of them in some capacity. So here's what we do. If we were to rewrite this as a multiplication question, my numerator would just be a squared, which is the same thing as a times a. And then my denominator would be 5 iterations of a, so a times a times a times a times a. And when we simplify this question, we're going to have a cancel here and a cancel here, and another cancel here and another cancel there. Okay, so we're left with the numerator is basically just 1. And then in the denominator, we have 3 iterations of a, which is the exact same thing as a to the third power. Okay, so what we just discovered is that 1 over a to the third power is the exact same thing as a to the negative 3. Okay, so in short, this is how you get rid of negative exponents. So if you're ever dealing with a to a negative number, the way you get rid of it is by moving it to the denominator and making it positive. So if I give you a to the negative nth power, a way to rewrite that is 1 over a to the positive n. Okay? Once you move it, it becomes positive. Okay? But also, if you have a negative exponent in the denominator, you could also move it to the numerator by making it positive. So if you ever have a situation where you have a negative exponent in the denominator, all you have to do is move it to the numerator and make it positive. So this should be the exact same thing as just plain old a to the nth power once it moves to the numerator. Okay, so let's do a few examples. If we have 6 to the negative first power, this is not done yet. It is illegal to have a negative exponent. We got to get rid of it. How do you get rid of negative exponents? By moving it from where it's from. So this one is starting in the numerator, it's starting above everything else. So in order to get rid of that negative exponent, I'm going to change this to 1 over, and it moves the denominator, it just becomes positive 6 to the first power. Okay, simplify that even more, it should just be 1 over 6. For example B, we have 1 over n to the negative third, negative exponent. We have to move it. Starts in the denominator, so we move it up to the numerator. Once we move it, it becomes positive for the exponent. It should become n to the third. Okay, for the next one, we see negative 4. This entire quantity is being raised to the negative second power. Okay, right now it's starting in the numerator. It's starting as just a plain old integer or number. We have to move it to the denominator. It should become 1 over, and rewrite it exactly as you see it. Negative 4, but once you move it, it becomes a positive exponent squared. If you wanted to simplify this even further, it should be the exact same thing as 1 over negative 4 times negative 4, which should be 1 over positive 16. Negative times negative is a positive. Okay, for example D, got to be careful here. We have negative 2a, b raised to the negative third power. Okay, for this one, because there's no parentheses, the only thing being raised to the negative third power is just the b. So when we ultimately move that thing to the denominator to make it a positive exponent, the b is the only thing that's going to go. Okay, only the b is being raised to the negative third power. Everything else has to stay. So when we rewrite this, we're still going to have a negative 2. We're still going to have an a, but in order to get rid of that negative exponent, the b has to move to the denominator, and it becomes b to the third power. Okay, if we look at example E, right now, the entire quantity, a times b, is being raised to the negative third power. Okay, everything inside my parentheses is being raised to the negative third, but not the 2. So the 2 stays where it's at. 2 stays on top. But the a times b will move. It'll become a times b. Once you move it, it becomes a positive. Okay, but we can also simplify this even further. Remember, what is our rule? If we have a product raised to a power, what we can do is we can distribute this 3 to every single piece. Should be the exact same thing as 2 over a cubed, b cubed. And then the last one, okay? This time the entire quantity 2 times ab is all being raised to the negative third power. The way we get rid of the negative exponent is we have to move it to the denominator. So it should become the exact same thing as 2ab raised to the negative third. Or excuse me, once you move it, sorry about that, it becomes positive. We'll keep going. We can get rid of the parentheses if we distribute this 3 to every single piece. Still 1 over 2 to the third power, a to the third power, b to the third power. Simplify this a little bit further. 2 to the third is the same thing as 8, a to the third, b to the third. That's the version written without parentheses.